This next thing we're going to do here is a laser power test. We want to see how much power is coming out of the laser modules themselves before they shine through the dichroic mirrors and the laser galvo mirrors. So what we have in front of us here is a laser BA 2-watt power meter. It's pretty simple to use. All you got to do is make sure that that sensor is in the path of the beam, and you can take a measurement. As you can see right now, it's sensing a little bit of the light right now coming from my overhead lamp right there. Okay, and here's the red power test. Alright, it looks like we're peaking just over 700 milliwatts there, so not too bad. And here is the green laser power test. The green laser will fluctuate a little bit. It's just the nature of it, of a diode pump solid state system. Yeah, so it seems to be hovering right around the 800 milliwatt range. That looks pretty good. And finally, here's the blue laser power test. So here's a little note on laser power measurement. As you saw previously, I measured the green laser to put out around 800 to 850 milliwatts of power. The red was putting out about 700, where the blue was putting out about 1550. So we're talking like 3.1 watts of power right there. It's quite a bit of power. Now, when you buy a laser on eBay or something like that, and they tell you that it's, say, a 1-watt laser, that is how they're measuring it, directly from the modules themselves. They're not measuring it after the laser goes through the red and the blue dichroic mirror here, which on my laser, it drops from 3.1 watts down to 2.8 watts, and then passes through the galvo mirrors right there, which drops 2.8 watts down to 2.5 watts of power. So total, I'm actually getting 2.5 watts of power measured at the aperture right there. That is how a laser's power should be measured when you buy it. Because if you were to buy a laser off eBay or any one of the Chinese websites, it is not going to put out what they advertise. So before we do the step-by-step process of aligning the red, green, and blue lasers permanently here, I just want to go over the mounts on here and what adjusting each one of them does. So what you're trying to do is get that red laser there to say cross the path of the green laser right there, exactly where it crosses, right here at the red dichroic mirror. Now, in order to do that, you actually have to adjust this laser here up and down and left and right until it does intercept this green laser here, right here at the mirror. Now, what does adjusting those do right there? All those do is just control the direction that the red is going to reflect. That is all it does. The same thing over here in the blue. It only controls the direction that the blue laser is going to reflect. It does not control the lasers that are actually passing through the mirror. So what I want to show you on this part is how the dichroic mirrors do reflect light when you don't want them to reflect light. So for example, the green laser beam is supposed to be passing through that red one right there and passing through the blue one right there and then off to the gallows right there. As you can see, that's the main laser beam coming out. However, we still have this laser beam, we still have that laser beam. Some of the light will not shine all the way through it. Some of the light will be reflected off it. And as you can see, that is the light lossage we're looking at right here. Some of the light is actually reflected away. It's nearly impossible to get 100% out of it so it does not reflect any light at all. But this is just part of building a red, green, blue laser system. You can get some pretty expensive dichroic mirrors. I've bought a couple of those. You know, they're around 60 bucks each, and they work pretty well, but you still are going to lose a little bit of light. But anyways, that's the reason why you're seeing these laser beams shine out here. Those will be blocked by the housing, of course, when I put the housing on everything, and you won't see that. So that's what's going on here. So welcome to the step-by-step process on how to align the red, the green, and the blue lasers. So step one, the green laser, as you can see here, it needs to be adjusted so that it shines through this red dichroic mirror at any point, it doesn't really matter so much, through the blue one over there, and then strikes the X galvo over here, because obviously that's what's going to do all the work and create all the effects. So once you have done that, we can go on to aligning the blue and the red laser. So now we're trying to align the red beam. Now in order to do this, the red beam must intersect right where the green beam is intersecting the dichroic mirror that you see there. As you can see, they're right on top of each other. The red beam is a little bit more flat looking, where the green beam is a little bit more circular looking. They are different shapes and slightly different sizes, but they are intersecting at exactly the same point. You do not use a dichroic mirror adjustment, so it's knobs right there to adjust for this. You have to adjust the red laser mount that it sits on over there in order to make it intersect at the same point on the mirror. Once you have done that, then you can adjust the knobs to make sure that the red beam reflects off in the correct direction to strike the X mirror right there. And as you can see, there is now clearly two distinct beams that are on top of each other. There is a red beam, which is a little bit bigger, and there is the green beam right in the middle, which creates the yellow light. Let's take another look. There's the green beam, there's the red beam, and you can see how they clearly line up with each other. The red being a little bit bigger. It passed right through the blue, then out to the output. Now we're on to aligning the blue beam with the green beam. Now it's exactly the same process as aligning the red beam with the green beam. We have to make sure that that laser module over there, the blue laser is sitting in, is adjusted until it intersects the dichroic mirror right where the green beam is intersecting it as well. And once it gets there, you can take those big 3 screws right there and adjust those until the laser beam output of the blue beam is lining up on the X galvo right down there. And as you can see, there is 2 distinct beams right here. If I can get a better shot, you can clearly see how there's a blue outline and there is a green one going right through the middle of it. Let's take a look from the top. So, there's the green beam, the red laser is turned off, there's the blue beam, And there's a combination of the two. You can clearly see the green beam right in the middle of it. And there's the output right there. And that's the result. Now let's take a look at all of them on together. Let's take a look up here. There's a green beam, the red beam intersecting it, creating yellow light, the yellow beam intersecting with the blue to create white light. And there's the output right there. So what we're doing now is a full power test of the laser head here. All the mirrors and lasers have been aligned. Everything is Loctited, so it will not move anymore. And as you can see, I have the laser galvo head. It is removed for now. We're going to put that back in later. But for now, we just want to actually see how this thing works as a red, green, blue laser module at high power. I've already measured the output. It is a little bit over 2.8 watts, which is pretty bright when everything is on full power. And as you can see right over here, there's the laser driver area, and there's a cooling fan on it right now, and there's the heat sinks and everything else. And let's see what we got here. So that beam you're looking at is a full 2.8 watts. Very, very bright. And it is very, very hot. So everything is looking pretty good. The beam is looking very, very white, the way it should look. And the beam is very well aligned. So that's a white beam you're seeing there. So what you're looking at now is a complete test run setup here, just to make sure that everything is working the way it should, electronically and mechanically. The laser galvos right there, I need to make sure that those are actually pointing in the correct direction, and the only way I can do that is by powering up the galvos and giving it a straight laser beam. So that way it does exactly as my other two lasers do. I wanted to make it look the same during the show. So just to go over the parts again, take a look here. As you already know this part, this is a red, green, blue laser module and the galvo head right there. And as you can see, it is not secured. I can actually move it around a little bit because it's not secured to anything. And I'm going to do all that stuff later. As well as the red, green, and blue laser drivers right there. I can actually move those around too. They're not secured to anything. The fans here are temporary, just keeping them cool. And back there, those two boards are the X and Y galvo drivers right there, which power the mirrors. And over here is the breakout board / show card. Over there is the power supply for the galvo drivers, and that's the main power supply back there, the bigger one. So, we're going to test this out and get everything aligned and make sure it does work as it should. So I have the computer set here just to put out a white dot centered up so I know where center is. And now we just have to activate it. Now here's the problem. As you can see, this is looking straight onto it, and you can see the beam is going straight to the left. As well, it is going down and to the left. So we need to move the beam up and center it up a bit. Now in order to make that adjustment, you have to loosen that screw right there, as well as the screw right there. Those are actually what clamp the galvo mirrors in place. As you can see, those cuts right down the galvo block right there. So you loosen those up and you just adjust the galvo mirrors as you need to, and that's how you do it. Okay, you can see a very low power reference beam right there, and that is very well aligned. It's coming straight at me, as well as it is very, very level to the board right there. So everything looks like it's centered up and ready to go. So why don't we actually throw on some one of the files here and actually play something and see how it works. So here we go. This is actually playing Fly It Like a G6 without the music right now, but this is a file for it. Everything looks like it's actually working pretty good. You can see those two laser beams right there. That is the light leakage, the light that's wasted reflecting off the dichros right there. We can't really do anything about that except just get more efficient dichros, but it's just something that we kind of accept when we're making these. As well as the light that actually leaks off the top, as you can see it up there. That's the light that's actually going right through the top of the mirrors right there. It actually goes over the sides of it. So this is a 2.5 watt laser when it's running at full power, full white. So this does have quite a bit of power going on it. And it's looking pretty good. And don't look into the beam, that's not a good idea.